Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and hi everybody. So my next video is we discuss on some questions from the topic about moment about Aziz 3D. Okay, so let's say we discuss on this exercise. Okay, so look at this example. Let's we discuss together how to solve this kind of exercise. Okay, so look at this exercise 7.1. You can also refer from a book, Static Math Simple exercise 7.1. Okay, referring to this exercise, determine the moment of the P, which is 150 Newton. First about the diagonal BA. Okay, first about diagonal BA. So what is our BA? So what is our equation? BA. Remember that BA, not AB. So we have MBA equals to lambda BA dot with MB, or you can also choose lambda BA dot with MA. It's up to you. Which one is you must prefer? You can choose either MA or MB. So let's say we choose MB. I think MB is most easier, isn't it? So before that, we can find what is our lambda. So lambda BA. So what is the equation? So dBAX over dBAI plus dBAY over dBAJ and plus with dBAZ over dBA. So this is our lambda BA. So what is our dBAX? dBAX B2A 0, isn't it? dBAY equals to 0.3 meter and dBAZ equals to negative because direction is from B to A, so 0.15 meter. So from that we can actually find what is our dBA equals to 0.335 meter. So there is our dBA. So convert it into vector form, then what we have lambda BA equals to 0I because dBAX is 0 plus 0.3 over 0.335 J plus dBA, that one should be minus 0.15 over 0.335 K. So simplify again. So we have lambda BA equals to 0.896 J minus 0.448 K. So this is our lambda BA. Done first part. Okay, clear. Next part is we need to find MB. So basically MB equals to, if we choose, let's say we put this part as P prime. So R we can choose RBP prime cross with FP. Okay, cross with FP. So RBP prime. So what is our RBP? So RBP prime equals to RBP prime xi plus RBP prime yj plus RBP prime zk. So what is our RBP prime x? From here we can find this angle first. This angle. So what is our theta? So let's say this theta is here is theta and this is 0.35 and here we have 0.15, isn't it? So we can actually use this one is 90 degree, so we can actually use cos theta equals to 0.15 over 0.35, then theta should be 64.6 degree. So this is our theta. Next is, once we get theta, we can actually find what is our RBP prime x. So RBP prime x is actually 0.25 sine 64.6 degree. Alright, sines, because we need to find x from B to P prime. Here B to P prime, this one, this distance, so we use theta. So the answer is, what is our answer? Should be 0.226 and RBP prime y equals to 0, isn't it? And RBP prime z must be negative 0.25 cos 64.6 degrees. So the answer must be negative 0.170. Then convert to vector form, then RBP prime must be 0.226 meter I minus 0.107 meter K. So this is our RBP. Right, clear? Alright, next is what we have. We have FP. So FP we can actually have remember, this is first step. If I can show you, this is first step, this is second step, okay, and the third step is we can find what is FP in vector form. Okay, then FP must be, if you get this, alright, P is downward vertically, so we just only have negative 150 Newton J. So this is our FP. Alright, this is our FP. So we can actually find what is our step number 4 is, we can find what is our moment B. So moment B, so we have MB equals to RBP cross with FP. So what we have, 0.226 meter I minus 0.107 meter K cross with minus 150 Newton J. Then simplify MB, what we have, the answer of MB must be, I think you can cross with here. So I cross J, we have K, should be the answer. The final answer of MB must be negative 16.05 Newton meter I. Okay, and minus with 33.87 Newton meter J. Alright, so this is our answer of MB. Okay, so last step is we can solve what is our MBA using equation lambda BA dot with MB. So we already calculate lambda BA, isn't it? So 0.896J minus 0.448K dot with negative 16.05 Newton meter I minus 33.87 Newton meter J. So from here we can find what is our MBA by multiplying this one. J, sorry, this one is J, okay, sorry. J cross I is 0, J dot I is 0, J dot J. Look at this one. J dot J is 0, and then J dot I is 0, J dot J is 1. K dot I is 0, and K dot J also 0. So we just only have multiplying 0.896 times with negative 33.87. So the answer must be 30.2 Newton meter. Here we are. So this is our final answer. Okay, so hopefully you can understand this step of on how to find moment about moment A. So the answer is 30.2 Newton meter. Okay, so I just show you one example, then the rest you can study by your own, and then if any question you can leave your question in the e-learning, then we can discuss together if you still cannot if you still not clear about this topic. All right, so I think that's all for for today. So hopefully you can understand on this step. So the most important thing is the how you are going to find the vector of lambda and vector form of moment. All right, you must know how to find it. Okay, so that one is not much difficult as long as you can spend spend more time in, for exercise. All right, so then that is okay. Okay, so we stop here, then hopefully you can study by your own, and if you still not clear and you have a question, then just leave your question in the e-learning. All right, so thank you very much guys. Assalamualaikum.